Hello and welcome to the Junos live session. At this time, all participants are in a listen-only mode. If you have a question at any time during the presentation, please type it into the Q&A box on your screen. Now I'd like to turn the floor over to Muku Murthy.
Hi everyone, welcome to the session on Universal Access Solution. My name is Muku Murthy. I'm a product manager at Edge and Aggregation Business Unit responsible for Universal Access Solutions, specifically ACX Series, TCA timing appliances, and the overall timing solution. We have a bunch of slides to give you a good overview of the components of the Universal Access Solution, how they're managed, when they're available. You can type in the question anytime, and we'll probably get to the questions in the end. So here's the agenda. Provide you an introduction to what are the market drivers and how Juniper is offering a solution that addresses and also exceeds some of the market expectations. Walk you through some of the software features that how it sets us apart from the existing solutions and how customers can benefit from it. Then provide an update on the timing solutions. Juniper has end-to-end timing stories starting from Grandmaster all the way to the clients. We'll give you some details on that. And overall solution being managed by an end-to-end NMS, the features and what's available and how it's being delivered. We have some slides on that. And then talk about professional services, which is one of the key components when you have a large-scale solution like Universal Access, whether it's Metro E or mobile backhaul. Just a bit of a background here in terms of the market trends. With the proliferation of the smartphones and tablets has really given rise to a lot of new innovative applications, being able to deliver content, make the job easier, increase productivity, and this in turn has actually resulted in new user behaviors where users are more mobile, more nomadic, and they expect at least some level of computational accessibility, whether it is mobile or fixed. Maybe the degree varies, but there is an expectation of being able to interact and collaborate and be productive, whether it's on the move or at the desk. This has resulted in the wide adoption, increase in users, corresponding increase in bandwidth, and new challenges on the operator networks. So without the right architecture, essentially the operators who would optimize on the cost and not an optimal solution for long-term delivery of the services and being able to design a network that can adapt to changes in the service location or the service movement, or being able to evolve into introduce new services, essentially will face new challenges, either in terms of scaling or in terms of being able to logged into a vendor solution which is either proprietary or not being able to scale to the market demands. And this essentially has a business impact, and this is where many of the savvy operators would like to embrace open standards, embrace the network architecture that can get farther than the current demand, and being able to provide flexibility of being able to offer services, being able to extend to new realms. So this is the gist of the solution introduction for Juniper in terms of Universal Access portfolio. So this slide basically talks about our current success with Universal Edge. Juniper has tremendous success in terms of core and edge routers, and especially when it comes to edge, MX being the service delivery platform of a single platform that can offer residential broadband services, being able to offer business services such as L2, L3 VPNs, multicast services, be able to offer many of the performance monitoring functions, IPsec, whether it's JFlow or NAT services, and mobile edge as part of the mobile next solution as a single platform, even though the platform has various flavors to it. A common control plane, a common Junos, and common management platform has resulted in a tremendous success for the MX platform. This is the flagship product of the company. And with we being successful in Universal Edge, few years ago, we wanted to address into the access space, and essentially the thought process was, how can we come up with the technology and architecture that will allow us to be successful in access without offering a me-too solution. So with that, recently we introduced portfolio solution, which is ACX Universal Access Solution that provides similar functionality or the similar thought process that went into Universal Edge. With ACX and access and aggregation and the core devices that run a single Junos on a single control plane and seamless end-to-end services, this essentially offers the same service flexibility, the same scalable architecture, and the same resilient network design that made Juniper successful in Universal Edge. Just to set the stage, ACX, even though it's depicted here as a single box, it's a portfolio of solutions that has the integrated timing built into it with some of the features that sets us apart from the currently available products. We launched ACX in February this year at MPLS World Congress in Paris. Even prior to that, and now we have had a tremendous customer interest in this portfolio solution that complements the MX offerings we have. We essentially are offering 5 platforms this year, and some of the highlights are it complements the Universal Edge. It provides a equally feature-rich capability, whether it's Metro-E or mobile backhaul, available as both fixed and modular platform. Some of the highlights of the platforms are all the platforms are 60 gig full duplex at any packet rate capable. They provide a highly scalable architecture, essentially being able to deploy tens of thousands or even 100,000 devices in the access through a scalable MPLS architecture. All the platforms have an integrated precision timing 1588 V2, whether it's boundary clock or the synchronous Ethernet. Offer phase and frequency delivery, being able to suitable for 3G, 4G, LTE deployments. All these platforms have extensive end-to-end network monitoring, whether it's Y1731 or RFC2544 testing. They can provide a automated, proactive collection of SLA measurement data and provide a lot of visibility and visualization through Juno Space Management System Performance Management Toolkit. All the 1RU boxes that you see here are fanless design. As a result, in an extremely dusty environment or in an extended temperature environment with large number of access boxes, there's no need to maintain the fans or replace the fans on failure. And as I mentioned before, Juniper is known for open systems. There are no proprietary protocols or mechanism in here. The system is open at 3 levels. So you can have a Junos-based SDK that lets you write some interesting applications in the access or aggregation if a customer has a specific problem to solve. There is one example that I'll walk you through. At the next level is you can interface at the Juno Space SDK level, where you can write a management application enhancing the information already available through Juno Space system plus the device interface, either through netconf or scripting mechanisms. As a result, the open system and some of these features, the service provider or the Metro customer can be assured that they're not buying any proprietary system that will lock into Juniper only solution. Although we would be more than happy if they continue with the Juniper solution. This slide depicts the 5 platforms that are being introduced this year, and the differences are mainly in the kind of ports and the capability. So just before we go through this list, the FRS target that you see here, 2T, 3T refers to 3 Junos releases per year, so 2T refers to second trimester, July, and 3T refers to third trimester, November, and 1T is March. So there are 3 Junos releases, March, July, and November. The immediate 2 platforms that are available in July are 1000 and 2000. 1000 is a 1 gig with T1E1. 2000 is 10 gig with T1E1. Then at the end of the year, we have 3 more platforms coming. Essentially, ACX 1100 is a Gigi only platform, and 2100 is 10 Gigi platform with more SFE ports. ACX 4000 is the only modular box in this family with 2 mix slots that can take one of the 3 cards, 16 T1E1 or 6 Gigi or 4 port channel OC3 or 1 OC12 12 port. The commonality across these platforms are they all support SYNCHRONIZATION 1588 for both copper as well as the optical ports. They're all temperature hardened, minus 40 to plus 65. They all run native Junos. They're all HC300 compliant. The main difference is whether AC/DC is supported, whether it's modular or fixed, or whether there is PoE. The 10 gig platforms, which is 2000, 4000, and 2100, support PoE, 2 ports, 65 watt each, that can be used to integrate either microwave IDU or it could be part of some of the telemetry integration. All the platforms run native Junos, the same Junos that runs on MX. So most of the services that run on MX should behave identically on ACX. Not all services are on MX are available here. For example, VPLS is not there, but there is HVPLS support. Similarly, many of the IPsec and various other feature-rich for business edge platform on MX are not productized on ACX right now. I'll walk you through the software features in next slide or 2. Here is the picture of ACX 2000. You can see it's a front access platform. All the platforms are front access only. From left to right, you can see the power supply connectors followed by 2 USB ports that could be used for software upgrade or zero-touch deployment. I'll talk about it in next few slides. Then there's a console port with management Ethernet port, followed by a bits timing input-output, followed by 1 PPS and 10 megahertz. ACX 2000 has 16 T1E1 ports, so you can see that, followed by 8 Gigi ports. The last two are the power over Ethernet ports. You can see a yellow LED, followed by two Gigi SFP ports, followed by two 10 gig ports. As you can see, the backside is just mainly the heat sink and the ventilation. This is the picture of ACX 4000. You can see the modular, two modular slots up top, one having 6 Gigi copper SFP combo, other one having a blank. So the platform can take one of the 3 MIC cards available, 6 Gigi copper SFP combo, or 16 T1E1, or 4-port OC3, 1-port OC12. So if it's all Ethernet, you can have up to 22 Gigi ports and 2 10 Gigi ports, including the one on the baseboard. From left to right, it's pretty much the same lineup on the baseboard. Power supply followed by console management Ethernet, USB, bits timing, 1 PPS, 10 megahertz, Gigi ports, 2 of them, power over Ethernet, 2 SFP and 2 SFP plus. So the software feature, as I mentioned, it's wherever the features are productized on ACX and are relevant for the access and aggregation portfolio, they behave identically from MX, so there is no new learning involved, no new management scripts that need to be written. There's no new new training involved as well. So the top 3 categories where we really want to focus the ACX offering is the seamless MPLS, which provides a way to scale the access network to 10,000 to 100,000 of devices without increasing complexity of management or network build out. ACX family supports integrated timing, which we already talked about, and operational simplicity that comes out of a common Junos, a common control plane, and a scalable architecture, all supported by end-to-end NMS. We support E-line, both Ethernet as well as the MPLS-based pseudo wires. Multi-point to multi-point supported via HVPLS, L3 VPN, TDM, ATM pseudo wires, MEF certified product. Timing, the standard boundary clock, Syncy, slave, they're supported as well. This is not a switch, this is a router with also the switching functionality. So it supports the standard Junos IP MPLS portfolio, BGP, OSPF, RSVP, LDP with link node protection, end-to-end service restoration, these kind of features. And more importantly, it also supports full-featured OAM, port-based .388, service-based .1AG, Y1731 delay and loss measurement, both proactive as well as on-demand. So you could either kick off the troubleshooting based on a problem, or there could be a collection of SLA data for either trending or for providing information to the customer portal. MPLS TP, OAM, BFD, as well as VCCB are supported as well. Here's a slide on seamless MPLS, essentially to capture the architecture recommended by Junos to scale either metro network, access network, or mobile backhaul, where there could be thousands to 10,000. We have cases where there are 100,000 access devices. All need to be supported through a seamless architecture. Seamless MPLS is, some architectural configuration or selection of the already existing IP-MPLS portfolio that either through some selection of techniques such as LDP downstream on demand, BGP labeled unicast, L2 access to L3 through pseudo wire head end termination, provides a simplified architecture, a hierarchical architecture to build out access and aggregation networks. It specifically separates the service plane from the control plane, which is really important, whereby you can create LSPs and they're orthogonal to the pseudo wires or the other services that you create. So when you try to either move the services or add new services and introduce new services at different points in the network, you don't have to change the network design overall, because these are all intelligent devices that are capable of signaling and being able to be fault tolerant and adapt to the network changes. Again, it's worth mentioning this scales up to 10,000 to 100,000 devices, and we have techniques for node and link protection in case of failures, both head end as well as tail end, with a deterministic end-to-end 100 millisecond failure detection and restoration. We talked through the platforms, we talked through what lineup they have, the software features, and the architecture that we propose. And I've mentioned passive cooling, but I just want to use this slide to just walk you through the benefits of passive cooling. Whenever you have fans, especially in a dusty environment, anything that moves breaks down. The dustier it is, the quoted MTBS number won't be realistic. With no fans, passive cooling essentially is not, will remain robust and highly available even in the most dusty environments. Fans need annual filter cleaning, and if they're not field replaceable, certain percentage of fans fail in a large network, some percentage. These number of units, just because of the reliability curve, you need to keep replacing them because of the fan failure. And fans consume extra power. So low power that comes as a benefit of passive cooling also benefits from lack of fans. With this in mind, all the 1RU platforms that you saw, 1000, 1100, 2000, 2100, are positioned for extreme dusty and the environment where you expect reliability, and these are in large numbers that you want to have almost like a zero remote management, coupled with zero touch deployment that ACX supports, and RFC 2544 bandwidth testing, and proactive SLM measurement. There is every less reason for you to be able to manage these devices once they're deployed in the field. So I talked about the openness of the platform. There is nothing proprietary built in. There is open interfaces available at multiple levels, both at the Junos level, at the ACX hardware level, where if customer is interested, there is a hardware SDK that can be worked through to build a custom hardware in a specific environment, and the Junos Space SDK. So NSN has developed an application using Junos SDK on ACX and Junos Space SDK to provide a dynamic traffic congestion alerts in networks that were traditionally kind of assumed to be static. So 60% of the access networks today are microwave, and the microwave is usually planned to near capacity, and there is no expectation of the capacity change. However, the weather changes or few other events can change the available bandwidth, and as a result, there is not an easy mechanism to detect the available bandwidth and be able to route the traffic in the right way, either based on the user behavior or based on the network behavior. With the SDK running on ACX and being able to monitor the network capacity through either microwave links or fiber, NSN is able to offer a dynamic network even in the microwave scenario. You can get more details on this through either Juniper or NSN website. I want to talk a little bit about the timing because Juniper is one of the few vendors that can offer end-to-end timing. That includes Grandmaster, which is TCA 8500, and all the timing technology that's integrated into the MX platforms and ACX. We got this technology through Brilliant Telecommunication acquisition last year. Brilliant had deployments over in Tier 1 operators around the world, and this is a very robust and very proven technology that Brilliant had that's been integrated into ACX. So right from get-go, we have the ability to scale the boundary clock as well as provide end-to-end timing solution through TCA 8000, 8500 Grandmasters, SYNCHRONIZATION 1588 being available on MX MPCs, and SYNCHRONIZATION 1588 available on ACX as well. All being managed by Junos through not just the clocking hierarchy configuration through Junos Sync Manager, which provides a view of the clocking hierarchy flow from Grandmaster all the way to the 1588 slaves, but also being able to measure SLA and report and being able to manage clocking as a service as opposed to just another protocol that needs to be managed. So just to recap, we have TCS standalone Grandmaster 8000, 8500. I have a slide on that. We can go through it. ACX cell site router with SYNCHRONIZATION 1588, MX series, and Junos for management. So TCA 8000, 8500 Grandmaster is available in two variations, obviously 8000 and 8500. The main difference being on 8500 it is Stratum 2 holdover with rubidium, and in case of 8000 it is Stratum 3E with OCXO. Both have GPS inputs. They have all the standard inputs that any Grandmaster is expected to have, with highly scalable design that's been proven in many of the mobile networks around the world. And this ideal for IP backhaul and femtocell applications and being manageable via Junos both Grandmaster and the clients. So with this, I want to move to end-to-end NMS. A complex technology such as either mobile backhaul or Metro E with tens of thousands of devices can be rolled out very easily if there are some features enabled at the platform level, which ACX does, and also providing an end-to-end management system with open interfaces that can be integrated with the existing management system from the customer already has. Junos is an ecosystem that provides a that provides a ecosystem to host not just the network management application, but adjacent application that can rely on network management to provide a new set of information that customers can use. It's open, all the interfaces are published, and even the SDK is available to extend the capabilities. It's simple because of a common Junos and being a single management system for all the platforms that Juniper sells. You get a common management system to roll out services and manage. This is again elaborating on the flexibility and the programmability of Juno Space. There are some Juniper applications that we'll talk about, such as Network Activate, ServiceNow, that Juniper develops, and there are third-party applications that are built on top of Juno Space SDK to provide value-added applications. Here are some of the features and benefits of Juno Space as a management platform. It's highly scalable, supports clustering, so you can add clusters to either have more user sessions or to have more network elements to be managed and provisioned. It's modular, as I mentioned, new applications and interaction between the application via standard API. The key thing for me is whenever we talk to customers, the existing NMS systems have a way of introducing new features only as a software upgrade. So let's say you have ACX devices running, let's say, Junos 10.4. When you have to use some of the features available via Junos 10.5 or 11.1, you would have to upgrade the NMS system if it were the standard offering out in the market. But Juno Space takes a smarter approach through schema-driven management, where every Junos releases a corresponding schema. You can download the schema, import into Juno Space platform, then right away all the CLI, new CLI and features that have been added in 11.1 are available to you without upgrading NMS system and going through requalification. This allows you to introduce services in a customizable way through either device level templates or service level templates, and deploy them without having to wait for the native support in the application in case it's of urgent need for the customer, either from the troubleshooting perspective or from the basic domain, the adjacency perspective. And the last one being total element management, all the Juniper devices managed in the same way, inventory management, device templates, software image management, full configuration of devices starting from scratch. You just need to enable netconf, and after that you'll be able to manage the entire life cycle of the device. There's no need to configure a set of attributes on the device before you begin managing the device through Space. On top of Juno Space as an EMS platform, there are a bunch of applications specifically targeted for universal access. These are essentially giving you an ability to manage the life cycle through creating the LSPs, being able to create different services on top of LSPs. Transport Activate provides you LSP management and creation. Network Activate provides you a way to create services, and added to that there is a QoS design and OEM control that lets you add QoS profile in the context of a service or a LSP. Manage the per hop behavior, manage the SLA characteristics such as what do you want to measure, how do you want to detect, what is the timer interval of .1AG or BFD, and what action needs to be taken through OEM control. And the last one being the timing as a service management. As I said, Sync Manage application provides an ability to manage the clocking hierarchy and collect SLA data. So this is the overall view. I think we have talked about this for the most part. We start with the platform with all the configuration management, accounting, remote OS upgrade, with all the applications shown in blue, all accessible via a northbound API. There's also an inclusion of fault and performance management within the space appliance that provides both the device and service level fault and performance management. Zero-touch deployment is supported on ACX devices that allows operator to roll out tens of thousands of these devices without having to pre-configure them at the warehouse or having to send a qualified technician to the cell site or to the street cabinet where these are being deployed. Essentially, the workflow would look like you use Juno Space to configure a configuration profile for a device, and you either enable this profile via DHCP configuration or through a USB. From the warehouse, you take the stock device to the cell site or the street cabinet, turn it on. ACX gets the DHCP response as part of the space configuration location, and it can pull from there, configure itself, be available on the network, or it can use USB to go through a third-party management, the third-party access network to reach the management server. In both situations, what you're doing is you are delaying configuration of thousands of these devices, and you're centralizing that at the Juno Space management location instead of per site location. This also allows an RMA of the device, the workflow RMA plus being able to apply the previous configuration of the RMA device onto the new device. With the service and the solution complexity of universal access for either mobile backhaul or Metro E, there is definite need for professional services offering. As a result, Juniper has a qualified professional services that can help you in characterizing the network for timing, being able to suggest best practice recommendation, being able to design, test, implement, and provide optimizations as part of the service now offering. All of this is available at FRS, which is 12.2, and professional services being one of the key components of the universal access story. This is the last slide I have, and we'll take questions. Let me just go through the questions. So the first question is, what is NMS standard for? So I assume the question meant to be either what kind of interface, northbound interfaces are available. So with that, it's M2C is available as well as RESTful API to integrate to the rest of the workflow systems at the OSS level. So next question is, HVPLS will be in the next Junos release. So the answer is it's available at FRS. So the next question is, how is ACX Series positioned? Mobile network, something else? So considering this is a universal access, we have seen a bunch of market segment being interested, mainly mobile backhaul, whether it's 2G, 3G, LTE. Equally true is Metro E, where either business access or residential access, it's popular there as well. There are some other, the vertical applications such as smart grid. There are cases where, because it's hardened and it is passively cooled, where the real estate is too high, these devices are being positioned there as well. Next question, T1E1 multi-service ports, TDM, ATM, IMA supported at the same time on single device? The answer is yes. There's a question, without active cooling, what's the trade-off to MTBF with the higher thermal load? So the platform has been designed with, the thermal operating range in mind. As a result, in fact, because there are no moving parts, the MTBF is better than if the device were to have fans. So the MTBF is quite high. However, in temperatures that are higher in the range, the expectation is these are not directly stacked on one on top of the other. At least there is some minimal space between the devices. There is a question, are the interface modules hot swappable? Some are hot swappable, some are not, but many of the SKUs that are available in the modular ACX 4000 already take into account the interface diversity, and there are various SKUs available. There's one last question. Can you elaborate on the supported topologies with the ACX platform? Ring of rings, ring to spoke, hybrid, hub and spoke topologies. I mean, pretty much all variations are supported with point-to-point features as well as multi-point to multi-point being available via HVPLS. The one last question from hardware forwarding standpoint, is ACX architecture close to any existing Juniper product? You could say it is more closer to MX than any other. So there is a design guide that's available if customer is interested in knowing what kind of topologies have been tested and what is supported, what are the recommended practices. You can engage with your local account manager, and we can definitely help you to succeed. So this is about what I had. I'm still like 10 minutes from the session being complete, so unless there are any questions, we're done.
All right, unless we have any other questions, thank you everyone for your attendance and participation. That concludes today's session. Thanks again and have a great day.